Just like we've shown that LU factorization is a reformulation of Gaussian elimination, that, in our opinion, is a little bit more elegantly described than the usual Gaussian elimination was, we can take the forward substitution step that updates the right-hand side according to the steps in Gaussian elimination that were applied to the matrix. We can reformulate that as solving with a unit lower triangular matrix. So let's have a look at that. So let's let L be a unit lower triangular matrix. We're given both L and Y, a right-hand side, and we want to compute a solution vector Z. What do? Well, we like to partition things, right? So let's partition matrix L into the one that's on its diagonal, L21 below it, and L22 as the rest of the matrix, which itself is a unit lower triangular matrix. And then let's take Z and let's partition it into zeta1. We use a Greek letter zeta because it's a scalar, and Z2. And that has to be equal to the vector exposing the first element as psi1 and the rest of that vector as y2. What do we often do next once we have done a partitioning like that? Well, we multiply things out. So let's take this right here and let's multiply it out. Well, that gives us the vector 1 times zeta1, that's just zeta1, plus 0 times z2. And down here, I should have given myself a little bit more room. Down here we get L21 times zeta1 plus L22 times z2. And that, notice, is equal to psi1 y2. And that's it. So now we know that zeta1 is just psi1. And if we are overwriting our vector y with the solution z, then that means that we don't need to do anything with that first element. That's just like when you do Gaussian elimination when you're in the current row. You don't do anything with that row, and if you have an appended system, then you don't do anything with that element on the right in the same row as well. Okay, and then we look at this and we say, okay, we know that this must be equal to that, but by the time we get here, we know what L21 is, we know what zeta1 is, and we know what L22 is, and we know what y2 is. So, if we subtract L21 times zeta1 from y2, then we're left with having to solve L22 z2 equal to whatever that updated vector is. So we're left with having to solve L22 z2 is equal to y2 minus, and notice that we can do the vector times the scalar or the scalar times the vector. We prefer to think of this as a scalar zeta1 times the vector L21. And then what? Well, then we have computed this current entry, we've updated the rest of the vector, and we're left with having to solve a new unit lower triangular system, which means we go to the next step in the iteration, we expose the next element, and we do this again and again and again. And we'll call this variant number 1 because, as we noted before, we like to look for multiple algorithms for the same operation. Now, to my right here is the algorithm that summarizes this. And when you look at that algorithm, all of a sudden it becomes clear why we start our partitioning with 1, 1, 1, 2, 2, 1, 2, 2, and so forth. It's because we always index the current element, the current row, and the current column with 1, because that allows us to sort of freeze the current iteration and look at what the current computation is in that iteration.